Okay, in this particular video we're going to talk about how to determine the empirical formula of a compound. Okay, and remember, guys, what an empirical formula is. It is a formula of a compound that shows the smallest whole number ratio of atoms in the compound. Okay, so when you consider an empirical formula, what you can think about in terms of if it's an ionic compound, its empirical formula is also going to be its formula unit. That doesn't necessarily hold true if we are talking about a covalent compound, and we'll probably work some problems over either as a video or in class to show how to figure the molecular formula of a compound and giving the empirical formula. But for right now, just remember that an empirical formula is going to be the smallest whole number ratio. So here in this particular case, what we have is we need to identify once again givens and unknowns and then basic equations or pathways. Here we are given 2.36 grams of sodium, and we also are given 3.64 grams of chloride or chlorine. In this case, it probably, when you're looking at it, since we have a metal here and we have a non-metal, we're probably going to have some sort of an ionic compound, because we know a metal and a non-metal is an ionic compound. Our unknown here is going to be our empirical formula. Now, when you look at your unit analysis and you begin to realize that this isn't a simple problem necessarily, but it's not too hard. You just have to understand. If we're talking about an empirical formula for a compound, what we are referring to is what is the molar ratio of each element in that particular compound. If we told you to write the chemical formula for this, you would probably be able to tell me right away it's sodium chloride, NaCl, a 1-to-1 ratio. So you can anticipate that, should be able to expect that to happen. But here's how you would go about solving this. The first thing you have to do is you've got to determine the number of moles of each substance. So this is a multi-step problem. Determine the number of moles of each substance. Of each substance. And then what you have to do is you have to find the smallest whole number ratio from that number of moles. And your unit analysis goes in a little bit more detail with this particular thing. But here's what we're going to do here. We're going to figure out first that step number one there. We're going to determine the number of moles of sodium and then the number of moles of chlorine. So in this case, if we were to start out, we were going to go from, it was going to be going from grams to moles of sodium. So we're going to have 2.36 grams of sodium. And we know that for every 1 mole of sodium, looking at the periodic table, we got 22.99 grams of sodium. So that's going to end up with 0.1027 mole of sodium. Now if we do the same thing here, we've got 3.64 grams of chlorine, times for every 1 mole of chlorine. We have 35.45 gram of chlorine, and once again that comes from the periodic table. You're going to see here we have 0.1027 mole of chlorine then. And what you notice here, we have to then find that smallest whole number ratio. Well, we're really lucky here, because what you would find the smallest of the number of moles here and divide that into the rest of the values that you have to find that ratio. But like I said, we're really fortunate here. We have 0.1027 mole of sodium to 0.1027 mole of chlorine. And since they're both the same, you can just pick one, and divide that. So we're going to have 0.1027 over 0.1027. So that means we got 1 mole of sodium to every 1 mole of chlorine. So remember what a chemical formula means. This means that I've got 1 sodium to 1 chlorine. Because this number here represents number of atoms or ions in this case. It also indicates your molar ratio. Okay, so we would obviously never write Na1CO1, so we would just write this empirical formula NaCO, which is what we would anticipate it to be, sodium chloride, based upon our knowledge of the fact that sodium is a +1 and chloride is a -1. Crossover charges, drop sign, smallest whole number ratio. But we actually analyzed this with a set of scales and came up with that particular molar ratio. So that's one way of doing this problem. Now think, if you were given instead the percent composition, what you would do there is just add one more step here. If you would, with a percent composition value, you would just have to convert that percent composition then to number of grams. And you should kind of have an idea how to do that. So if we were given a percent composition here instead in this problem rather than number of grams, all you then is, that would be like saying then, in the case of sodium chloride, for example, that would end up telling you I have like 39.34% sodium and I've got 60.64% chlorine. So why don't we go ahead and problem some. So if you had 0.34 sodium and you have 60.64% chlorine, all you do then is you make an assumption there then. That means if I have 100 grams of the compound, okay, 39.34 grams of that would be sodium, and then 60.64 grams of that would be chlorine, and then you follow those same two steps, and you're going to go grams to moles, and then you're going to determine the smallest whole number ratio. Of this particular substance to that substance. You're going to go grams, moles, and then smallest whole number ratio. Okay, then you're going to end up finding a 1-to-1 ratio once again. So why don't you give that a try and see if you can do that, and we'll probably end up going over a problem like this in class. Good luck.
Made with Doodlecast Pro.